Welcome to the lecture number 60, dear students. In the last lecture, that is 59, we finished the theorem that if arcs are congruent, arcs intersected by chords are congruent, then those chords are congruent. Now this time we are going to study if chords are given congruent, then arcs intersected by those chords are also congruent. Now in this case, what is given? Chord PQ is congruent with chord RS. So chord PQ has intersected arc PMQ. Why do we find chord RS has intercepted arc R and S? So our aim is to prove. Our aim is to prove arc PMQ is congruent with our RNS. Now please try to understand the proof of this theorem. We are having two triangles, namely triangle POQ and triangle ROS. These two triangles we are having. Now I am going to prove these two triangles congruent, positive. PO congruent to RO. PO congruent to RO. Radii of the same circle, because these are radii of the same circle with center, therefore they are congruent. Then you will find OQ congruent with OS. OQ congruent with OR, OQ congruent with OR. So first one is PO congruent with RO, PO congruent with RO. Second one is OQ congruent with OR, OQ congruent with OR. The next to that is PQ congruent to SR. But PQ congruent to SR is given. PQ congruent to SR is given. Because you will find that chord PQ is congruent with chord RS. That is given. So you will find in triangle POQ and triangle ROS, three sides of triangle POQ are respectively congruent with three sides of triangle ROS. And therefore, triangle POQ is congruent with ROS by SSS test of congruence. They are congruent by SSS test. At once these two triangles become congruent, you will notice angle POQ is congruent with angle ROS. Angle POQ is congruent with ROS. POS is congruent with ROS. If POQ is congruent with ROS, then, but these are not, these are central angles. These are central angles. And you all know the theorem. If central angles are congruent, then corresponding arcs intersected by these central angles are also congruent. So you will be getting RPMQ is congruent with RS. Because if central angles are congruent, then corresponding arcs are also congruent. So this is also one of the important theorem, and this theorem may be asked for 3 marks, not more than that. So weightage of marks for this theorem is of 3 marks. So this is how you will find if corresponding arcs of congruent chords of a circle are congruent. So you will surely find O is the center of a circle, chord PQ is given congruent with chord RS. Naturally, you will find PO, OR, radii of the same circle, OQ, OS are radii of the same circle. Anyway, you can take PO, OS you can take, then OQ, OR you can take. That is going to become one and the same. And chord PQ is congruent with chord RS. Therefore, these two triangles are congruent by SSS test. Then later on you will get PMQ is congruent. That's all in this theorem. Now next to that, I am going to teach you one very important concept, and then I will begin exercise 3.3. Before that, try to understand. Cyclic quadrilateral. Cyclic quadrilateral. Try to understand what is meaning of this cyclic quadrilateral. A quadrilateral of which all vertices are lined on a circle is called a cyclic quadrilateral. Very simple definition that a quadrilateral of which all vertices are lined on a circle is called as cyclic. So this is how you will find this is a circle. If I draw quadrilateral ABC, so this is a quadrilateral ABC. Clear? So a quadrilateral of which all vertices are lined on a circle a quadrilateral of which all vertices are lined on a circle is called as cyclic quadrilateral. Very simple definition of quadrilateral of which all vertices are lined on a circle. So quadrilateral ABC is cyclic. Quadrilateral ABC is cyclic quadrilateral, because you will find its all vertices are lying on the side. Very important properties that we are going to study related to this cyclic quadrilateral, but that is a proof. So at present I would not like to focus much on those properties. Important property that opposite angles A plus C as well as B plus D is equal to 180. That opposite angles of cyclic quadrilateral are always supplementary. That is very important, and there is a special proof is there. So I would not like to go that much in detail right now. Secondly, this is also one more important property, that exterior angle is congruent. This angle is congruent with this angle. Exterior angle is always congruent with remote interior angle, as well as you. This is also one of the very important property of cyclic quadrilateral. So cyclic quadrilateral is a quadrilateral of which all vertices A, B, C, D are lying on a circle. Opposite angles are always supplementary. There is a proof for this. In addition to that, exterior angle are always congruent with each other. So that's all about cyclic quadrilateral. I don't want to waste too much time for this. So let's go for the next exercise 3.3. Exercise 3.3. So 3.3. In 3.3, you will find question 1. 3.3, question 1. First of all, I'll prefer to draw figure. Figure is given. This is a circle here, and in this circle you will find C is the center, and you will get different points. This way is joined D, E, F, D, E, F. So D, E, F are the points which are lying on the side. In addition to this, they have also given point G over here. So D, E, F, G are the points. Center is C, that is important. Center is C. In addition to this, it is given angle ECF, angle ECF is equal to 70 degree. This is given. Next to that, measure our DGF. Major arm DGF is equal to 200. Find major arm DE. Find major arm DE and DEF. Okay. Look at this figure first. These points D, E, F, G are called as concyclic points. Concyclic means the points which are lying on the circle are called as concyclic points. Okay. Now they have given angle ECF is 70. This is given as 70. And major arc DGF, this whole arc DGF is given as 200. Is given as 200. And question asked is to find out D. ECF is 70. ECF is 70. Now you will notice one thing. ECF is a center line because C is a center. Therefore, major arc EF is equal to angle ECF. So this arc is also 70. I have explained you the concept of center line. So major of central angle is equal to intercepted arc. So proof or answer. Answer is major angle ECF. Major angle ECF is equal to major arc EF that is equal to 70. That is equal to 70. ECF, this is 70, so major arc EF is also 70. So I am going to write here this central angle property. Central angle property. So you find here major angle ECF. This angle, central angle, is equal to intercepted arc. Okay, now please try to understand. We have to find out major arc. Major arc question is DE. Okay, let's find out DE. Now you will notice sum of all arcs of a circle are 360. But you know, major arc DGF is 200, as well as major arc EF is 70. So 200 plus 70 will give you 270. But sum of all arcs is 360. So 360 minus 270 will give us 90. So you will be getting arc DE as 90. Okay, so I am going to write here major arc DGF plus major arc EF plus major arc ED, that is equal to 360. Sum of arcs of the circle. Arc BG F plus R EF plus R DE is equal to 360. So 200 plus 70 plus D. So the next step is 200. This is value of BG plus F 70 plus major arc DE, that is equal to 360. That is equal to 360. So major arc DE is equal to I'm going to transfer this to the right hand side. 360 minus 270. Then for major arc DE is equal to 90. So this is all I got to measure arc DE as 90. At once you will get major arc DE. Question is find out major arc DE. Okay. We find the value of major arc DE. We got it as 90 degree. Alright. Now we have to get arc DEF. So DF is 90 plus 70 is equal to 160. So major arc DF. This is, you can say, answer of 1, answer of 2. Major arc DF, major arc DF is equal to major arc DE plus major arc AF is equal to major arc DE, major arc DE plus major arc AF. Try to understand, major arc DEF is equal to major arc DE plus major arc EF. So major arc DE is equal to 90 plus 70. So we get it 90 plus 70. So that is equal to 160. So major arc DEF, major DEF is equal to 160. If you want to give support to your answer, you may write arc addition property. Arc addition property. So please look at this sum carefully. They have given this angle to us. So we got EFS 70. Next to that, they have also given us this whole arc, which is 200. So our DGE is equal to 270. 360 minus 270 will give us our DE 90. Then our DEF is equal to 90 plus 70. 90 plus 70 is 160. So this is how you will find. This is not too much difficult sum. Easy to understand. Only the very important concept is sum of arcs is 360. Sum of arcs is 360. Question number 2. Exercise 3.3 only. Question number 2. In question number 2, that is figure 3.3s. Okay, I'll write given first. Given 3.3, question 2, page 64. Triangle QRS given. Triangle QRS is an equilateral triangle. Is an equilateral triangle. Is an equilateral triangle. Prove that we have to prove measure arc RS, or you can say arc RS is congruent to arc QS congruent to arc QR. And you will find the second one. Measure arc QRS. Second one is to prove that measure arc QRS is 240. Okay. Figure is there. Triangle is given as QRS. So question is, if arc RS plus R, we have to prove this, of course. This is very simple, because just now, before this lecture only, we have studied very important theorem in the previous lecture. What is that? If sides are congruent, or in this case these are the chords, if chords are congruent, then arcs intercepted by the arc conduit. Isn't it? I explained you again that if chords are congruent, then arcs intercepted by the arc conduit. This theorem we have finished already. So by giving the reference of the same theorem, we can say RS is congruent with RS is congruent with QS as well as is congruent with QR. Reason being that they are corresponding arcs. So RS is congruent to QS is congruent to QR. RS congruent to QS congruent to QR. Reason is corresponding arcs of congruent chords. Corresponding arcs of congruent chords are congruent. That is what we have studied in the theorem. So, because triangle QRS is an equilateral triangle, is an equilateral triangle. Is an equilateral triangle. Therefore, chord QR, therefore, chord QR is congruent to chord RS is congruent to chord. These chords are congruent. Why these chords are congruent? Very simple. Because triangle is an equilateral triangle, and you know the basic property of equilateral triangle that all its sides are congruent. But these sides in this case are chords. So you will find, because triangle QRS is an equilateral triangle chord QR, congruent to chord RS is congruent to chord QS. So our first part is over. Fine. Now next to that, measure R. Second one, measure R. RS plus measure R. QS plus measure R QR, that is equal to 360 degree. Sum of all arcs of a circle is 360. So RS plus QS plus QR is 360, and all these three are same. All these three are same. Measure R QRS is 240. Measure R QRS. We have to keep this as right. Now you will find measure R QS is equal to 3 times measure of QS is equal to 360. Why this is so? Because all arcs are congruent. All arcs are congruent. So measure arc QS is equal to 360. 3 times 360 because arcs are congruent. Arcs are congruent. Okay, all these 3 arcs are of the same measure. Therefore, it is 360. So measure arc QS is equal to 360 upon 2. So measure arc QS is 120. Measure of QS is 120. So naturally, measure of QRS. Measure of QRS is equal to 360 minus measure of QS. That is equal to 360 minus 120. That is equal to 240. This is the answer of our question. Question is to prove that measure of QRS is 240. Now after this lecture, in the next lecture, we are going to study very important theorem which is called as the inscribed angle theorem. So by using that theorem to prove this results is more easier than this one. But in this case, so far we have not studied inscribed angle theorem, so that's why I did not use the theorem over here. Otherwise it is more easy, because you will find if this is 60, this is 120, because angle is half the, this is 60, this is 120, as well as this is 60, this is 120. And if you have to find out QRS, 120 plus 120 is 240, very simple. But okay, anyway, this way also we can do this sum, because you will find that all these arcs are congruent. So 3 times QS is equal to 360. Therefore, if you transfer 3 on right hand side, measure on QS is 120. But you will find QRS plus QS is 360. Okay, QRS plus QS is 360. So if I transfer QS on right hand side, 360 minus R QS, that is equal to 240. So that's all in this second sum. Now I am going to do the third sum. Third and last. The last sum of this lecture 16. So last sum of this exercise as well as this. I will draw the figure first. Two chords are given, A, B and C. Figure is 3.39. Page number is 64, correct. So here you will find A, B and C. A, B and C, there are two chords given. And in addition to that, it is given not only this, but it is also given chord AB is congruent to chord C. Chord AB is congruent. This is chord AB is congruent to chord C. And to prove that arc AC is congruent to arc B. Arc AC is congruent with arc B. Okay, fine, no problem as such. Okay, arc AC is congruent to arc B. Fine. Now please try to understand. Very interesting one. That arc AC we have to prove is congruent to chord arc B. Okay. Now you will find in proof. Let's use what is given chord A. Chord A is congruent to chord C. Chord AB is congruent to chord CD. That is what is given. Now, if chord is congruent, then you will find corresponding arcs are congruent. So you will find arc ADB is congruent to arc ADB is congruent to arc, because what is given chord AB is congruent to chord C is congruent to arc DBC. Try to understand again. If chord AB is congruent to chord CD, then arc ADB, the arc which is intersected by this, and you can also find arc CB or DBC, one is corresponding arcs corresponding intersected arc of component of congruent chords is that clear? So you will find here in figure 3.39, if chord AB is congruent to chord CD, prove that arc AC, sorry, I am drawing a little bit wrongly, C is here and D is here. Slight change you have to make, but they are the same, because you will find chord AB same way, AC, ACB, okay, ACB. I have to make change here also. And chord CD, CD, I have to take CBD. Sorry. Try to understand again. chord AB is equal to chord CD is given, then chord AB is equal to chord CD. AB has intercepted our ACD. Chord CD has intercepted our CBD. See, corresponding are intercepted arcs of congruent chords. Now you will find, if I call this as 1, measure our ACB. Measure our ACB is equal to measure R. ACB is equal to CBD. Same. Now look at the figure. ACB is equal to measure R AC. Measure R AC plus measure R AC plus measure R BC. That is equal to ACB is equal to AC plus BC. That is equal to measure R BC plus B. Measure R BC plus measure R BC plus B. Same things will get cancelled from both sides. Our BC is a common in our ACD, BC is there. In our DBC also, our BC is there. So they will get cancelled. So we will be getting measure our AC is equal to measure our BD. Here you may write arc addition property. Arc addition property. So try to understand again that chord AB has intercepted arc ACD. Chord DC or CD has intercepted arc DBC. That is what is written. Later on, a reason is given corresponding intercepted arcs of congruent chords. Again, I write here ACB is equal to CBD. So ACB I write it as measure arc AC plus measure arc BC, and CBD I can write it as measure arc BC plus measure arc B. So BC and BC will get cancelled. So we left with measure arc AC is equal to measure arc BD. That is what we have to prove. Please look at this down properly. So here I finished lecture number 60. So thank you very much. Trying to understand all the concepts of chords, intercepted arcs, corresponding chords, congruent chords, congruent arcs, congruent arcs, congruent chords. These are things. And the next lecture will meet with very important theorem that may carry 4 months also. That is called as infradyne theorem. Thanks a lot for watching this video, dear students, as well as please listen this video also in very sincerely so that you will get clear idea. Thank you very much. God bless you.